So the last type of word problem that we're going to look at for this unit is mixture problems. Okay, so these problems are a little bit different than the ones that we've been looking at, and I want to start by really emphasizing what the difference is. Okay, so this problem, we get a candy store that is selling a mixed bag of two kinds of chocolates. They want to sell a total of 15 pounds of chocolate. Okay, the milk chocolate costs $1.20 a pound, the white chocolate costs 90 cents a pound. How much of each type of chocolate should they combine in order to have a mixture that's worth $1 per pound? Okay, so this problem is different than the other ones that we've looked at. Okay, so I want to compare what's different about this problem and say this problem from the last page of your notes where we were talking about selling 10 adult tickets and 14 child tickets, and it was a total of $140, right? So what's the difference between those two types of problems? So on the ticket one that we looked at, okay, the information that they gave us is we were dealing with how many tickets were being sold, right? And we set up our equation where we were saying, okay, the amount of money per ticket, we were multiplying by the number of tickets, right? And then we added to that the amount of money for the other kind of ticket times its number of tickets. And that equaled altogether the total amount of money. Oops. There we go. Total amount of money. It's a weird dollar sign, but bear with it. Right? And that makes sense because when you multiply money times the number of tickets, right, this multiplies to a money number. This multiplies to a money number. So it makes sense that you would add money and money together and that would give you total money, right? So that's why those problems made sense. Okay, now this problem, this mixture problem, is a little bit different. When we look at the information that they've given us, right, they're telling us how much it costs per pound. So when we set up over here, it's going to be sort of similar, right? We're going to look at the amount of money per pound, and we're going to multiply that by the number of pounds, right? And we'll do that for both of the different kinds of chocolate. Okay, but here's what the difference is. Before, they gave me a total amount of money that was spent. Okay, and that makes sense for that problem. But when we look at this problem, right, I'm multiplying the amount of money times the number of pounds. This is still going to multiply to give me a money answer, right? So when I'm adding these guys together, this should equal money. But when you look at what they actually give you in the problem, they tell you a number of pounds. Okay, so this equation, this should equal money. It should equal the total amount of money, but that's not what we're given in this problem. So what we're going to have to do to kind of tweak this to make it work is we're just going to have to calculate the amount of money here. So I need this to equal the total amount of money. Well, how do I calculate that? Well, I'm going to multiply the cost per pound for the new mixture times the number of pounds for the new mixture. Okay. And that is going to multiply to a money amount, and then that fixes our equation. Okay. So the difference is that in the other equations that we did, we would just have one number here. Now we're going to have a product of two things, just like how we had a product of two things everywhere else in these equations. Okay. So that's the part that's different. So let's go through this problem and actually do it out. All right. So what we're going to set up here, first of all, we need to define our variables. So I'm going to use, let's see, there's milk chocolate and white chocolate. So I'm going to use M and W. Okay. So I'm going to use M. They're asking us how much of each type. So M is going to be the number of pounds of milk chocolate. And W is going to be the number of pounds of white chocolate. Great. Okay, so let's go ahead and set this up. So what information do I have here? So we're selling 15 pounds of chocolate. Okay, so that right there, that gives me one of my two equations, right? How many pounds plus how many pounds should equal how many pounds, right? So the number of pounds of milk plus the number of pounds of white should equal a total of 15 pounds of chocolate. Okay, so this whole equation is just about number of pounds. Now, my second equation is going to be about the money part, okay? And this is what we kind of talked about. So the milk chocolate costs $1.20 a pound. So you're doing $1.20 times the number of pounds of milk chocolate plus 90 cents for the white chocolate, okay? And that's going to equal, it's not going to equal just $1, right? That doesn't make sense. You know that doesn't make sense, right? If you're multiplying $1.20 times however many pounds of milk chocolate you have, it's not going to be $1. Okay. So what this is going to equal is it's going to equal $1 times the number of pounds. Okay. And we happen to know that the number of pounds was 15. Okay, so this number 15 actually shows up in both equations. It shows up in the strictly talking about the amount one, and then it also shows up in this one that's about how much money. Okay, so how much money times the number of pounds plus how much money times the number of pounds equals how much money times the number of pounds. All right, and then this is the system that we're going to solve. Okay, so what I'm going to do is just solve this by elimination. So just like we've been doing, I think I'm going to multiply this equation by 90 cents so that I can cancel out my W's. So that'll give me 0.90 M plus 0.90 W equals, and then I don't actually know what that is. So let's go to the handy dandy calculator. 15 times 0.9 is 13.5. Okay. When I recopy this second equation down, I'm going to actually multiply those two numbers together. So it's going to be 120M plus 0.90W equals, and then $1 times 15 is $15, right? Okay, cool. And now I'm going to subtract these two equations. So those guys cancel out. When I subtract this, that's going to be negative 30. Okay. When I subtract this, 15 and 13.50, that's $1.50, so negative 1.5. Okay, and then I'm going to divide both sides, and that's going to work out to M equals, so 1.5 divided by 0.3 is 5. So M is 5. All right, and then from there, that's a pretty easy substitution into that top equation. I know that it's going to be 5 plus W equals 15, so W is 10. Okay, so written as a point, my solution would be 5, 10. Written as a sentence, they should mix, right, 5 pounds of milk chocolate with 10 pounds of white chocolate. Okay, so the solving is not different. The solving part is the same. Mostly the setting up is the same. Okay, the one key difference is that this isn't just going to equal a total amount of money because they don't tell you the total amount of money. Okay, if they had said we want to mix these together so that it works out to a total of $15, then we would have been okay, right? We could have jumped right to here. But they didn't tell us that. They told us it was $1 a piece for 15 pounds. Okay, so that's what the difference is, and you really got to pay attention to that. This is like the most common mistake that I see on this test is people forget that this part has to be a little bit different for the mixture problems. Okay, and mixture problems are going to be problems like this one, anything where you have like different percentages of things, like if you have some percent of some acid and a percent of another acid and you're mixing them together, that's a mixture type problem. Okay, so those are the kind of things that you're going to expect to see when you're doing these mixture problems.